Now, I hope you don't mind being recorded. You can, if you get in the front and you go on YouTube later, you can see yourself. You can go, yes, look, I am a film star now. Yeah, sort of. But I will also send your teachers the presentation and the questions and the answers so they can see them and share them with you. Um, a couple of us were talking earlier. I'm not going to say who because they might get nervous. I don't think so. One of the best ways to work at chemistry is to do questions, to do many, many questions. Today we will do some questions, but as you get closer and closer to the examination, you want to do more and more questions, and you need to get the answers. Now, some people think it is important to do the questions to test yourself. No, you want to do the questions so you become familiar with the questions, so you are used to the language and you can learn the answers. We are not, now we are getting towards the real examination. We're not worried about understanding so much as passing the examination. So you need to learn the answers to things. So here we go. So today is organic chemistry. I've had several schools ask for organic chemistry. And we are going to do organic chemistry 1 and 2. That's the form 3, form 4 chemistry. There is quite a lot of it. There is quite a lot of industrial chemistry, uh, fractional distillation, cracking, why rubber is vulcanized, and so on. Some of which is very important, some of which is interesting. And I will teach you that later. To start with, we are going to find out a little bit about what you know, but also we are going to learn the basics about what the molecules are about. We are going to learn the names like homologous series and functional group and so on. And we are going to learn to name organic chemicals and to be able to draw them because they are quite often questions which you will come across. I'll just share something with you now. So this is a set of questions. These are UK questions, but they're where they are asking you to name certain questions. Sorry, certain molecules. There are other ones. Here are some from KCSE. Where are we? Here are standard KCSE questions. Here it comes. Here it is. These are collections of questions. This is about a group of hydrocarbons, and you have to work out what their formula is from the number of carbons and the RMM, or the relative formula mass, and so on. Then sometimes they ask you to talk about physical properties. This is about the boiling points of the first 5 alkanes. And sometimes they ask you to write equations. This is cracking. Sometimes they ask you to name a chemical. Name this one, name this one, name this one, and so on. So you have to be confident in naming. They also ask you about isomerism. They ask you how to draw them, and so on, and so on. So what we're going to do today is we're going to do naming of organic chemicals, and then we're going to do some questions. We're going to do some questions in it. Okay, here we go. So let's share this. So this is my presentation for today. Your teachers will get it. And it is called, come on. Whoops, sorry. My apologies. It is called Naming Organic Molecules. So here we go. There are 3 parts to naming any organic molecule. There is no need to write all this down. But what I want you to know is that I use with my students 3 different colors and 3 different shaped boxes. A circular one, doesn't matter about the color, a rectangular one, and a triangular one. And we're going to go through what those are. So what we do is we look for what is called the functional group. We're going to look for the functional group. Then we are going to look for the longest continuous carbon chain. And then we are going to look to see if there is anything else on the molecule, something that we would normally call a substituent. Okay. Now, I'm going to stop sharing for a minute. Can anybody tell me what a functional group is in organic chemistry?
Hello.
So can anybody tell me what a functional group is? Because they sometimes ask you for 1 mark or half a mark, what is a functional group? Can anybody tell me? Yes, no, perhaps? Who is confident? I'll tell you if you want. Who is confident about what a functional group is? Who is maybe I'm right? And who has no idea at all? So are you confident? Maybe some idea and not confident. Glory, how are you feeling today? Yes, maybe no. Glory, about functional group. One person is very confident. That's good. St. Mary's, I guess, is Wamwini.
Okay,
Yes,
I can say,
go for it.
okay, I think functional group is a specific group of atoms within a molecule that is responsible for the for the chemical reactions of one molecule.
That is very good. Say it again.
Functional group is a specific group of atoms within a molecule that is responsible for the characteristics of chemical reaction in a molecule.
I like that very much. Well done. There is one addition I would say to that. This molecule is methane. This is CH4. It is what we call a saturated hydrocarbon. That it is all only single bonds, and it is a hydrocarbon. That means it only contains hydrogen and carbon. Simple. This doesn't have a functional group. So what we say a functional group is anything which makes the molecule different from an alkane. Okay, so a functional group, exactly as the student at St. Michael's said, is a group of atoms or an atom or two which determines the reactions and the physical properties of that molecule and makes it different from an alkane. I'll give you an example of why that is important. Alkanes burn. Their major use is for fuels. But so do alkenes, alkynes, alkanols, alkanoic acids, esters, they all burn. So what we are looking for functional group is something which makes it different from an alkane. Okay? Can anybody tell me what a homologous series is? Anybody tell me what a homologous series is? I mentioned methane is an alkane. That is a homologous series. What is a homologous series?
Hey.
I can try.
Oh, I think, okay, yeah, you can. So Mary's, you got in too late. Okay, so Michael's go again. Homologous series.
Homologous series is a family of organic compounds with the same functional group, similar reactions, and members that differ by different molecules.
And what was the last bit?
It's a similar, let me just repeat the whole statement. It is a family of organic compounds with the same functional group, similar reactions, and members that differs in a molecule.
It's almost as though you're reading that. It's a very good definition. Yes. What a homologous series is, sometimes people just refer to it as a family of organic chemicals. but they have something in common, like all families have something in common. The first thing is that they have the same functional group. The second thing is that they therefore, have very similar chemical properties. The third thing is they have the same general formula. Now, we will come across general formulas, CnH2n plus 2, and so on. And the last thing is that they have a gradation, that is a change in physical properties like their boiling point, melting point, whether they dissolve in water, and so on. Okay, so back to my presentation. Here we go. So we look for the functional group. We are naming, okay? So if you want to make any notes, we are naming organic chemicals. So we look for the functional group. Then we find the longest continuous carbon chain, and we have to count them. And then we look for any substituents. That is, things which are not the functional group and are not the main chain. So we're going to look at a few examples. So here's my first example. If you feel fairly confident, you could try naming this, writing down your name for this now, and then you can check it when I've gone through it. What I'm going to do is I'm going to go through quite a number, of examples, just so that those people who are confident can name it straight away. And if you're not confident, maybe you will learn how to do it and to become confident. So I look at this and we remember that, guys, can we just mute, please? Who is it? Guys, can we just keep muted, please? Thank you. Okay, so here we go. So what we are looking for is something that makes this not an alkane. Okay, we are looking for something that makes it not an alkane. Alkanes are carbons and hydrogens and only single bonds. So in this, and this is what I do with my students, I get them to draw a circle around the functional group. Then I get them to draw a rectangle around the longest continuous carbon chain. Now it has to be continuous, in other words, joined to each other, but they maybe go round the corner and so on. And from that, I'm going to name this because this tells me it is an alkene. So that tells me the end of the name, which is ene. This tells me that it is 4 carbons long. And very soon you will know meth, eth, prop, bute. So it is butene. The functional group is always the end of the name, butene. But I also need to recognize that the double bond could be here where it is, or it could be between the first and the second carbon. So what I say is, no, it's not on the first carbon, it's on the second one, and I call it but2ene. The 2 tells me where the ene is. Okay, before we go any further, who got that right? Who thought it was but2ene? Put up your hands. Let's have a look. Hang on, I'm just gonna pick a few people. Who have we got here? Oh yes, Dandora girls have got some Marys, yes, some Wamawini, I think. Okay, that's good. So let's go again. So here's another one. Here's another molecule. There we are. This one's really easy. It's an alkane. And because it's an alkane, it ends in ane and it has 3 carbons. So it's MEP, meth, eth, prop, and it's just propane. But I'm now going to show you one which shows you what a substituent does. Here's a very similar molecule, but one of the hydrogens here has been replaced with a new carbon, and the carbon has been covered with hydrogens. It's still an alkane, but it's not propane anymore, not just propane, because it's now got this other carbon on. So go back to my naming system just for a minute. Circle round the functional group, rectangle round the longest continuous carbon chain, triangle round any substituents. So here it is. So there it is. That bit makes it propane, but this bit is a one carbon unit, and that will make it methyl. So the methyl, some people pronounce it methyl, it doesn't matter. Methyl is a one carbon unit, sort of off the main chain, adding to the main chain. So this is methyl propane, and I need to say that it's on the second carbon. So it's 2-methyl propane. So when I'm teaching my students, I get them to color code. So that is the bit which comes from the longest continuous carbon chain, and that is the substituent. Okay, how about this one? Have a go if you can, see if you can name it. It's not terribly difficult. So just have a go. If you think you know the answer, write it down, and we can check with you in a minute. We can see whether you've got it right. I will go through it in just a minute. It's a very simple one. I'll give you a hint. It is made in Kenya anyway from sugarcane. Yes, absolutely, St. Mary's. Do we need the one? Do we need the number one there? Show me closer, Dandora. You're too far away. You're going to need longer arms. Yes, that's correct. Well done. Okay, so here we are. So usual thing, we circle the functional group. This is the bit which makes it not an alkane. The longest continuous carbon chain is just 2. There are no substituents. That makes it an alkanol. An alkanol. In many parts of the world called alkanol, in many parts of the world just called alcohol. This is a 2-carbon unit, and therefore it is just called ethanol. Now, because it's ethanol, do we need a number in this gap? No, because if I call it ethan-1-ol, if I move the OH to the other end, it would still be ethan-1-ol. So it's just ethanol. Be careful of that, because the examiner, being a bit mean, might decide not to give you the mark if you put the 1 in there. Here's another one. Here's a new functional group. What is this functional group? What does this make it? This makes it what homologous series is this? COOH. I think many of you will know. This is in chemistry 2. It's an alkanoic acid, also called just carboxylic acid. You may find, for instance, if you left school and you studied in Kenya and then you moved to the UK, say, to further your studies, you would find this is called a carboxylic acid. So sometimes the homologous series has different names. That doesn't really matter. Now, the longest continuous carbon chain here, you may think, oh, well, it's 2 there, but no. The carbon which is part of the functional group, as we saw with ethanol, is also the longest continuous carbon chain. So that will make this, that is anoic acid, is the end for that, and this will make it propanoic acid. Propanoic acid. Easy. Okay. Here is a little bit more complicated version. Just have a look at this. Oh, there's something missing. Sorry. Something weird has happened here. Hang on. Let me just, here, there we are. I'm showing you the molecule here, And the main molecule, here's the functional group. I'm not telling you what it is. There's the longest continuous carbon chain, and it's got a chlorine on. Each of these two has a chlorine on. Now, with a chlorine, we normally call it chloro, and it goes at the beginning of the name. So, can anybody name these two chemicals? In your examination, it is unlikely it will be this complicated. But can you tell me what these will be called? Just have a look at it for a moment and then show me your answer if you want. Anybody? Very, very nearly, St. Mary's. The second one is not quite right for a reason we'll see in just a minute. Well, Sharika, hold it up so I can see it. Oh, where's it gone? Very good. That's one of them. What about the other one? That's correct, Sir Mary's, Brian. Well done. That's very good. I'm going to go back to one of my naming points right at the beginning here. Um, Here in the longest carbon chain, you count the carbons and you number them from the end nearest to the functional group. So when the functional group is on there, you have to number from there. Okay, that's really important. So let's go to these guys. Here they are. So that means I number from this carbon here. I hope you can see me on the left-hand molecule. That carbon there, because that's the one which is on the functional group. So I would number from here, number one here, two, and three. That means that the one on the left is called 2-chloro-propanoic acid. I've put it in the colors that I was using for the functional group, the longest chain, and the substituent. There's the circle I would draw. Here's the rectangle, and there's the triangle. That means that this one, you might be tempted to call it 1-chloro, but it's not. We have to number from this end, so it's 3-chloropropanoic acid. Okay, let's see if you can do some. Whoops, sorry. Oh dear, what's happened there? Okay, let's see if you can name these. So here are some molecules I'm going to draw, and I'd like you to see if you can name them. Remember, find the functional group first, then the longest continuous carbon chain, and then any substituents. So see if you can name that one. I'll show you how to do it in just a minute. I'll show you how to do it in just a minute if you're not sure. Glory, does anybody know the answer? Usharika? Very good. Well done, Brian. Excellent. Usharika, Silver Spring, Glory. Anybody? Can anybody name it? Gloria saying no. Show me, bring it closer. If somebody has an answer, please, in Glory, a little bit closer. That's excellent, Osharika. Oh, sorry, a little bit closer, please, Glory. Oh, nearly. Glory, I'll show you why that's not quite right, but it's very close. Let me show you. Okay, everybody, here we go. So I'm not going to go through all of them, but I want to show you this one. So I first look for the functional group. I'm doing this, okay? So I know it's going to end in anol, okay? Maybe it's going to be something ol just before the ol to tell me where. Then I'm going to look for the longest continuous carbon chain. This is the longest continuous carbon chain here, and that makes it butanol, okay? And then I also have a substituent. My substituent is here, and that is a methyl. Sorry, it's not very good on this color. But I haven't yet numbered my carbons. Well, the end closest to the functional group is this one. So that's carbon 1, 2, 3, and 4. So the OH is on 2 and 2-ol. And the methyl is also on 2. So it's 2-methyl butan 2-ol. Would it be okay if you said 2-methyl but 2-anol? Yes, they wouldn't mind, but this is the perfect one. Okay, let's do another one. Let's just get rid of all of that. Okay, here we go again. Here's another one. Here's another one. Try this one. Come on, Silver Spring. It's time to go for gold. You can do this. Oh, Brian's got it again. Oh, wow. Well done, Silver Spring. Yes, you guys are good. Well done, Silver Spring, and well done, Osharika Girls. This is really good. I'm very impressed, so I'm going to have to make it more difficult. So that one, I'll just show you again. There it is. The longest continuous carbon chain. It hasn't got a functional group, so the longest continuous carbon chain. It could be any of them. Let's say I decide to make this the longest continuous carbon chain because it's 3. So that would make it propane. And it's still the same 2 substituents. I'll try and make them a better color to see. That one, whoops, that is a terrible triangle. And there are 2 of them. And because of that, we call it dimethyl. And they're both on the second carbon, whichever one I start at. So although it's okay to write 2-dimethyl, it's better to write 2,2-dimethyl propane. Okay, one more. We're going to do one more naming because I think you're pretty good at this, so we don't need to spend too much longer doing it. We'll do the next bit. So here's another one. Here we go. Now, this is not quite so easy to see. So sometimes it's worth, if you get a formula like this, if you get a what we call a structural formula written out like this, it may be worth drawing it out so that you can identify all the different bits. But you may be able to do it anyway. I should tell you that an OH, which is on the chain but not making it an alcohol, in other words, this one here, is named as hydroxy. So if it's in a chain but it's not making it an alcohol, it's hydroxy. Any answers? Oh, at Silver Spring, their brains are working very hard because there was a gentleman who had a hat on earlier and he's had to take it off because his brain is working so hard, producing so much heat. 4-hydroxyheptanoic acid. It got to say acid on the end. Got to say acid on the end, Brian. Have you counted your carbons right? So I'm now going to do what I think you should do if you're not too sure, and that's to draw the whole thing out. So when I draw it out, I tick off the carbons or cross them out so I know that I've covered them. So this is CHOH, HOH, CH2, CH2. Oh, Brian's changed his mind. C double mondo OH. Check it again. 1, 2, 3, 4, 5 carbons. Correct. Brian, anybody else? Anybody else got an answer there? Anybody got an answer? Don't look so frightened, Usharika. It's okay, you can do this. Silver Spring, you're really good at naming. Let's have it again. Glory, come on, you can do it now. We've got the technique. I think you can do it. Let's see an answer. Come on, Glory. Glory for gold. Mathari mixed. Well, we've already had one answer, so I'm going to move on because what I want to do is to move on a little bit. So I'm going to do what I say you should do each time. So the first thing is I look for the functional group, and alkanoic acid is more important than an alcohol. Then I look for the longest continuous carbon chain. That is this one. Whoops, hello. Yellow, please. That is this one here. I number them 1, 2, 3, 4, 5. And then I'm looking for substituents. The only one is this OH here, which I said was called hydroxy. And it's on the fourth one. So it's 4-hydroxy something. 4-hydroxy, well, it's 1, 2, 3, 4, 5 carbons, which makes it pent. And then the functional group makes it anoic acid. Wow, if you got that, you're amazing. Well done. Okay, let's go back. So the other bit that we have to be able to do is this, and that is turning it round. So instead of naming, it's drawing. And we're going to see, because I think you're very good at this, we're going to go from here. And I'm not going to give you all the answers. I'm just going to say, try this. So this is draw the structure for butanol. I should tell you that in an exam, if you draw a carbon with OH like that is okay, but it's better if you draw it O, and then it's actually an angle like this. But the angle doesn't matter. So if you did this That's okay. So this is okay. This is much better. This is not too bad. Okay. So if you draw OH, it's better if you draw out all of the bonds in the molecule. Okay, everybody have a go. Butan-2-ol. Let's see if you can do it. We're already halfway through the lesson, which is amazing. In fact, slightly more than halfway through. Let's see if we can do this. Glory, we have an answer. Let's have a look. Let's have a look. CH3, we're missing an OH, I think. Aren't we missing an OH? Where's the OH? Glory, you were really fast then, but we need the OH. Careful, Brian, that looks like a double bond to the O. That's Silver Spring. Silver Spring gets the first completely correct. Silver Spring is the king. Silver gets gold. Wow, hey, that's good. Okay, so very good. Let's just go back to it and make sure that everybody is happy with this. Butan-2-ol. So what I'm going to do is I'm going to go for butan first. 1, 2, 3, 4. Ol, OH on the second carbon. Does it matter which end I start with? No. In organic chemistry, we often start at the right-hand end. So I'll do that. And then I would put all the hydrogens on to make sure I've got them all. I'm not going to do it now. I'm not going to waste your time. Next, chloromethane. Nice and easy. Chloromethane. Can you draw the structure? You should be drawing out the whole structure, not just CH3, CH2, CH2, that sort of thing. See if we can do this. Who's got chloromethane? Chloromethane. Nice one. Well done, Brian. Good. Easy. Yes. Silver Spring, tell me, why do you do it on bits of ripped out paper? Why don't you just keep the bits of paper in one book? You're right. You are correct, Silver Spring. What is your name, please, Silver Spring student, with the ripped up paper? Do you only have bits of ripped up paper? What is your name, please? That's quite funny. Poor old Silver Spring, they don't have books, they just have little bits of paper. Hold it again. Hang on, I can't see it properly. Hang on. A little bit further away. Is it Tim? I can't see. A little bit further away. Show me again. Was it Timothy? I couldn't see exactly. Timothy, well done, Timothy. Really good. But keep the bits of paper in the book. You might want to do them sometime. Okay, so chloromethane, very simple. One carbon because it's meth, and it ends in ane, and therefore it's an alkane. That it's one carbon, four bonds, one of which, any of them, is the chlorine, and that's it. Great. Next, whoops. Next, ethanoic acid. This is to check that you can count. Ethanoic acid, it's a race. Will it be Timothy or Brian? Who will it be? St. Michael's, I can see you. Hang on. Oh, yes, you're right, St. Michael's. Well done. Sorry. Oh, St. Mary's. Faster than a speeding bullet. And Timothy's there as well. Oh, no. Timothy, double bondo. Double the bond, the O above has to be double bond. Always count. It's very important. Sorry, Glory, let's have a look. Correct. Yep. Usharika, very close, but it's the anoic acids have a special functional group. Bit closer, please, Glory. Little bit closer. Bit closer. Bit closer to the camera. Nearly. Let me just show you, everybody. Everybody, this is important. The acid bit looks like this. So there's a carbon and it has a double bonded oxygen because oxygen has a valency of 2. And then there's a O H, like that. So it's not O and it's not OH. It couldn't be because the oxygen would have to have three bonds. Can't be that. Can't be that. So this is it. For it to be eth, it has to have two carbons. So it's got a carbon with just hydrogens on. Okay, last one. 2,2-dimethylpropane. It's a race. It's a race. Who can do it? Fastest. 2,2-dimethylpropane. Brian is racing. Timothy is racing. Timothy's have. It takes longer for Timothy because he has to rip out a piece of paper first. Oh, yes. I'm not going to allow you CH3 on that. You have to have all the bonds out. No, Brian, I want to see all the bonds. St. Michael's, can you do this? Come on. Come on, Osharika. Still waiting for not CLs, not CLs, Silver Spring. Osharika, yes, but I wanted to see the CH3s drawn out. This is quite important. If they ask for the structural formula, there are two structural formulas which are okay, but when they ask you to draw it out, you could write, this would be perfectly correct because there isn't anything else it can be like this. But this is not a full structural formula. A full structural formula has to show all, however boring it is, all the bonds and all of the atoms. It is a bit boring drawing them all out. I am getting very bored of doing this, but it is important that you do it exactly like this. Okay, the whole thing drawn out like that. Okay, I think that will do on that bit. Okay, let's move on. Hang on. Oh. Okay. So, hopefully, yes, Sir Michaels, that was chloromethane. Yes, you're absolutely right. Oh, you're missing one hydrogen on there, but otherwise, yes, well done. Well done. Okay, I think everybody is pretty good at that. So let's have a look at some KCSE examination questions. We have about 20 minutes left, so we'll look at some proper examination questions now.
Sasa nataka mkae vizuri ndio hapa nimeconnect.
Mute, please. Could you mute, please? Mathari, I've just muted you. I hope you don't mind, because I think you were just unmuted by accident. Okay, I'm going to share something with you. Somewhere. Where are we? Right. Okay. So here are some more general organic questions from paper 1 and paper 2 from various ones. I'll make it a little bit bigger for you. Here it is. So these are proper KCSE questions, which we're going to concentrate on because they are quite straightforward KCSE KCSE questions. So in the first one, it says, look at the table, and you have to basically work out what is happening. If it has two carbons, see this on the left-hand side. Oops, what is happening? Why can I not point? Okay. Strange. Something weird is happening on my computer. Anyway, let's have a look at this. So have a look at this bit here. It says there's the number of carbons of, carbon atoms per molecule. There it is RMM of a hydrocarbon. It tells you it's a hydrocarbon. Work out what the one with 2, 3, and 4 would be, and then tell me what the general formula is and the homologous series they belong to. And then draw the structural formula of the fourth number of the series. Okay, so there's the whole question. Let's see if anybody can do it. I'll be coming to you and asking what you think of the answer in just a moment. I'm going to see if I can draw on it. So to give you an idea of what I would do, I would go, okay, if it is C2 and it weighs 26, well, C2 weighs 24, so that would mean only 2 left over, so it would have to be 2. So if you do the same for the 3 and the 4, and then you work out the general formula, so it's going to be Cn H something N. Let's see if we can work out what it is. See if anybody can do this. Come on, Glory, you can do this. Yes, you can. It's not just about smiling and laughing. You do that very well, but I think you can do chemistry as well. Come on, Glory. Wouldn't it be cool if Glory got the gold? Then they can take the gold and the glory. Okay, very good. So C3, I'm going to carry on. C3, well, C3, that's 36. So how many hydrogens have I got? Well, if that's true, then I've only got 4 left over. If it's C4, that's 48. 48 up to 54 is 6. So I've got H6. So what is the general formula of these? Well, C2H2, well, CnHn, but are these all the same? If I draw out C2H2, it would have to be, if I've only got one H on each one, that means it's an alkyne, triple bond. What about C3H4? 1, 2, 3. Let's assume for a minute it's a triple bond again, then that would be a single bond. Will that fit? Well, this will have one hydrogen. This has got 4 bonds already, so no hydrogens. And this would have 1, 2, 3. Okay, so that fits. So that's an alkyne, that's an alkyne. C4H6, does that work? So do you see what I'm doing? I'm just experimenting with my answer. So let's give it the alkyne triple bond. All the others are just single bonds. This carbon would have just one hydrogen. This one, second one doesn't have any. The third one has 1, 2, and the fourth one has 3. That's C4H, 1, 2, 3, 4, 5, 6. All right. Okay. So they are all in the same homologous series. So how do I work out the number of hydrogens? Because in the first one, it looks like it's CnHn. Well, that's daft. The second one, it doesn't work though. So what does work? Try and think about what it is. And the homologous series, I've already said what it is. So see if you can struggle on with that. Now, draw the structural formula of the fourth number I've done there. So try and think about that second question, the general formula. Next question. We've just dealt with what a homologous series is. Let's make sure we can write it down properly. It's okay to call it a family. So what do they all have in common? They have the same general formula. They have the same functional group. They have this very, very similar reactions or chemical properties. And they have a gradation or a sort of very similar, but a trend. So I'll call it that trend in physical properties. Now, I know it looks like I haven't got enough room here. I've made this a smaller question than it was in the real examination paper. Okay, so family, same general formula, same functional group, similar reactions, and a trend in physical properties. Let's just list 3 characteristics of a homologous series. You see, this is why we do questions which are similar, because then you can go, oh yeah, there it is. There's my answer. 3 characteristics, same functional group, similar reactions, same general formula, trend in physical, yes? And explain the term functional group. Well, the young scientist from St. Michael's did a great job on that. A group of atoms, or an atom or group of atoms, which tell us how it is going to react. It's the part of the molecule which makes it different from being an alkane. Different from being an alkane. Okay, it tells us, it is the part of the molecule which tells us how it is going to react. It also tells us its physical properties because, for instance, a 2-carbon alkane is a gas, but a 2-carbon alkanol is a liquid, and that's because of the OH. Okay, here's a different sort of question. 2 questions here worth 3 marks. That's quite a lot of marks in KCSE. If you remember from last lesson, 3 marks, that would make it worth 4.5 minutes. If you remember, it was 1.5 minutes per mark. And therefore, you would be able to say, I can spend 4 minutes thinking about my answer first before I write it. Really important. Think about it first. Construct it in your head. If necessary, write it down in bullet points first, in little bits first. State and explain the trend in the boiling points of the first 5 alkanes. Okay, what do I know about the alkanes? Oh yeah, that's methane all the way to pentane. Do I know anything about pentane and methane? Oh yeah, this one's a gas, I know. I think pentane is liquid. So maybe by doing that, you can help yourself a little bit. So what is the trend? What is the trend? Are they getting greater? Are they getting smaller? And it says state and explain. Now it's 2 marks, so it'll be 1 mark for that and 1 mark for this. So you don't have to write too much, but you do need to do both parts to it. And then say in the second part, Why are the enthalpies of combustion negative? I'll tell you something funny, and that is that there are no positive enthalpies of combustion. If there were, we could create an interesting kind of air conditioning where we could have candles burning and they were taking in heat. That would be cool. Huh. Cooling. All right. State and explain. Does anybody want to tell me can you state what is the trend in the boiling points? What happens to the boiling points as you go from C1, C2, C3? What happens? Do they get more or less? Higher or lower?
Excuse me, teacher.
Go for it, Sir
Um,
Michael.
I wanted to ask a question.
Yes.
Could you please pardon on the characteristics of halogen series? I was stuck a bit there.
On the halogen series,
Yes.
do you mean in this organic chemistry?
Yes, like the previous question before the trends of boiling points. I think it was question 3.
That we've just been doing. Let me just go back. Hang on, St. Mary's. I'll come and have a look at your answer in just a minute. Question 3. The characteristic of homologous series and explain the term functional group. That bit.
Yes, that one.
What was the problem?
I did not understand the characteristics
Oh, I
of
see.
homogeneous.
Okay, the characteristics just means tell me 3 things which is true of a homologous series. So any homologous series, let's say I'm going to go for the answers that I just did because I just defined homologous series in the question above, right? So the characteristics are that they have the same functional group. They have very similar reactions, and a trend in physical properties are the best ones to give. So it is just asking you 3 things that we know about a homologous series. Characteristics just means that tells us something interesting about them. So the best thing to say is that they have, you could say same functional group, you could say same general formula, but the best 2 other ones are similar reactions and and then the trend in the physical properties. So, for instance, it isn't saying any particular homologous series; it's saying of any homologous series. Okay, it's any. It isn't saying any. It doesn't use the word any there, but it doesn't mean if it wanted you to be specific about alkanols or alkanoic acids, it would say. So it just means if I have a homologous series, tell me 3 things that I should know about that group of chemicals. So you would say, well, let's say I'm talking about alkanes, but it would be true about anything. They are all the same functional group. They all have the same reactions. In other words, they do burn, they do not react with bromine water, and so on. And they have a trend in physical properties because, as we're just about to see here, the boiling points increase with the number of carbons. So because we're running a little bit short of time, I'm just going to give an answer here. The first bit is that, oh, hello, that's an interesting color. Let's do this one. Boiling points increase as number of carbons increase. That's the first thing. That's stating it. That is telling me what is true. And explain is as the molecules get bigger, van der Waals forces increase. Now, if the van der Waals forces increase, van der Waals forces increase because van der Waals is proportional. This is above what you need to say to number of electrons in the molecules. As the number of molecules increases, the van der Waals increases. You wouldn't need to say that because that's too hard, but I'm just telling you for those people who are interested. So the first mark is for boiling points increase. That's 1 mark. And as the molecules get bigger, the van der Waals forces increase. That's the second mark. Why are enthalpies of combustion of alkanes negative? We did energetics last time. We're nearly out of time. Why are they negative? So if I wrote it for, if I wrote a thermochemical equation for methane, I would write this. Delta H is negative 890.4 kilojoules per mole. That's a little bit of a geeky thing to do. Why is it negative? Would anybody like to just turn on their microphone and tell me why it is negative? Or possibly just turn on your microphone and just talk nonsense. Mathari, I'm muting you. So, anybody want to tell me why it is negative? What does the negative tell me? Brian?
Okay, I think the reaction is exothermic.
Yes, and therefore heat is lost. Good, that's it. You would get the mark for the reaction is exothermic. It would be good to add, therefore heat energy is lost from the reaction. That's what it means. If you look at my equation, it says 1 mole of CH4 reacts with 2 moles of oxygen to make 1 mole of carbon dioxide, 2 moles of water, and it loses 890.4 kilojoules of energy. That's what it means. It means it loses that. State the product of complete combustion of alkanes. There it is, carbon dioxide and water. Okay, that, ladies and gentlemen, is the end of the lesson. I hope it has been useful. I'm just going to stop the recording. Wow.